The Banana Pi has been around for a while now, but I thought I'd review one that isn't so common, the Banana Pi router. So before we get started, I'd like to promote my Patreon page. Patreon is a way of supporting a content provider by regularly donating. One of the goals of this channel is to help the maker make decisions for their next project. So your regular donations will effectively help me help you. So I was looking back at some of my old videos. I think I've improved. Hi! Hi! This is an Arduino Uno. Let me tell you about Arduino Unos. So then you connect up the I2C. Hang on, that's not I2C. So essentially it goes around. No, it doesn't.
Okay, so it's not a real first time unboxing, but hey, I have to keep things consistent. This is a Banana Pi R1, which is essentially the same as a Banana Pi M1, but with an inbuilt network switch. So let's freeze frame it here and see what we have on this little baby. Starting from the top right, working clockwise. First of all, a standard 3.5mm audio out jack, a standard SATA connector which supports up to 2 TB disks. The black plastic is just to avoid the SATA disk from shorting out components. LiPo battery connector, MIPI DSI connector, UART GPIO, even more GPIOs, infrared receiver, green LED which is user controllable, red power LED, MIPI CSI camera connector, 1GB DDR3 RAM, the mighty dual-core A20, fully compatible Raspberry Pi GPIO headers, onboard microphone, 5V 2A micro USB power connector, micro USB OTG, USB 2.0 host connector, HDMI, and 5 1GB Ethernet ports. On the flip side, we have the micro SD slot supporting up to 64 gigs, power button, reset button, Wi-Fi, optional antenna connectors, and the Broadcom Ethernet switch. The Ethernet switch is capable of providing 7 ports, but only 5 are available, but more on that later. The R1 supports essentially either Android or Linux, with the Linux flavors being Ubuntu, Kano, Raspbian, Bananian, Arch, Fedora, OpenSUSE, and OpenWRT. Download the OS of your choice and you're set to go. For this review, I used Raspbian, Bananian, and OpenWRT. Load it up onto an SD card and chuck it in. I used a wireless keyboard and mouse since there's only one USB port available. Then connect up HDMI, Ethernet, and finally the juice. I also used a simple 120GB SATA disk for my tests. Make sure you connect it up with the power off because the SATA port is not hot swappable. Once powered on, you should see the Raspbian desktop in around 30 seconds. Okay, since the company provides a GPIO header, it needs to be tested. My really complicated LED test to start off. Okay, no surprises there. What about I2C? This time I'm using an I2C based Lux sensor from Adafruit, and I connected it up to one of the I2C buses that is externally available. Note the Banana Pi actually has 5 I2C buses, but my Lux sensor is easily found on bus 2. A simple Python script will do the trick here, which works okay as well. What about the SPI bus, my handy dandy Max 7219 to the rescue? And that worked. Oh, hang on a second. Doesn't seem to work. Now why is that? It seems that Raspbian isn't fully supported on the R1. So I booted up with Bananian, which is supposed to have much better support for the R1. Yep, okay, SPI works well on Bananian. This is to be expected as Bananian is targeting the Banana Pi. Shame that we have all these different distribution forks around and we can't settle on one OS. Oh well. Just for something different, let's see what some GPIO bit bashing is like using a single wire humidity sensor. But seems Raspbian is having the same issue here. Moving back to Bananian seems to fix the issue, however. So moving back to Raspbian, let's see if the infrared port works. Make sure you have the IR module loaded in the kernel, which should create a device file. I used xmode2, which shows up pulses being sent from a standard remote control. Yep, all okay there. What about the onboard mic? I've always thought it a bit ridiculous, really, putting a mic on a PCB, but anyway. Let's pull up the mic gain and see what it picks up. I played back on a simple non-amplified speaker.
Hello, this is a test.
Yep, okay. The bad sound quality is to be expected from a cheap condenser mic, but is acceptable. The R1 also has a power management chip installed, so you can query the current load in milliamps easily enough from either the battery or AC. And there's also control over the onboard green LED. Well, sort of. The kernel blinks the green LED periodically, which sort of makes it a bit useless.
The R1 is being marketed as an open source router. This is great, but how does it perform on the network side?
Before we get on to testing the network, I should highlight several things. First, the onboard Broadcom switch is what's called a Layer 2 switch. It's a cheap switch with minimal control. This essentially means that it's not a hardware router, and so any routing of network packets will need to be set up in software by you. I'd suggest using OpenWRT if you want to use this as an internet router. Second, you'll need to configure the switch if you want to use it as a router. The command swconfig isn't available on Raspbian, but has been ported from OpenWRT to Bananian. You can always just copy over the binary from OpenWRT and use it under Raspbian if you are desperate. swconfig will allow you to create VLANs and query all the stats available on the switch. Third, the ports are ordered in the logical manner of 3, 4, 0, 1, 2. Okay. If you don't configure the switch properly, you can end up with devices not being able to be seen on the upstream network. As you can see, the laptop connected to one of the ports wasn't able to obtain an IP address.
If you're desperate to use anything but OpenWRT and you want to use the Banana Pi as a router, be prepared for a steep learning curve, or else just use OpenWRT.
So after all that fiddling around with VLANs and switches, how did the Ethernet perform? Not so good actually. I've seen much better, but within the low end of acceptable. Local loopback tests came up with some very poor results as well. The Phoronix test returned around 218 seconds, which, putting it into perspective, is not even on the open benchmarking comparison graph. On the Wi-Fi side, connecting to an access point under Raspbian was a little dodgy. For some reason, it connected okay the first time, but every other time after that it wouldn't. I had to manually remove files and reboot to fix. Next on to SATA disk performance. I ran a battery of tests using the Phoronix test suite. AIO stress came up with 10 megabytes per second, which is frankly abysmal. The disk I was using is similar to this disk, so 3 times slower. The SQLite test was right down the bottom of the list, really bad, and was half as bad on the FSMark test. More than 3 times worse on the D-Bench test. Read performance isn't so bad using IOZone, but slows down a lot on writes. The compile benchmark shows once again how bad things are. And unpacking the Linux kernel, well, it's damn slow, almost 3 times slower than the last entry.
If you're thinking of using the R1 as a NAS box, then I'd really look at something else. But if you're happy with a third of the performance, then why not? Then there's OpenWRT.
The OpenWRT version on their website is a little old, but let's give it a blast. I was interested to see if Wi-Fi was more stable under OpenWRT, so I enabled the radios, set a password, and I was able to connect without issue from my iPhone. Nice. There are a number of tests I didn't have time for in this video, but I will post an update later. Let me know if you want me to add anything to this list.
So that's it for this week's review. I have further information on my website and in the description below. So next week's review is going to be on the Tinsy 3.5 and 3.6. Thanks for watching. If you enjoyed this video, then don't forget to like. And supporting me on Patreon allows me to keep on publishing videos like this. So if you get a lot out of these videos, I'd appreciate the support. See you next week.